Hello everyone, you're welcome back to class. I remain your arithmetic teacher. Still in our discourse on trigonometry. In our last lesson, we looked at what problems leading to trigonometry. Today, we'll continue with another aspect of what problem, that is angle of elevation. Now, an angle of elevation is the angle between the horizontal line and your line of sight when you look upwards. Now, looking at this figure, this is a boy trying to look at this aircraft over here. So the first thing you should note is that there is a horizontal line, which is this. And this horizontal line signifies the boy looking straight. So if you are to keep your head straight and you are to look straight, this will result to this horizontal line. So this is the horizontal line when you are looking straight. But when you want to look at this aircraft, it means the boy has to raise his head above. So from his eye level down to the aircraft will result to this line, which we call line of sight. So this is the line of sight. Then between the line of sight and this horizontal line, which is the boy looking straight, an angle is formed right here. And this is the angle we call the angle of elevation. The angle of elevation. Then the distance of the object is looking, in this case, the aircraft. The distance from the aircraft down to this horizontal line is a perpendicular line where we have our 90 degrees. So let's proceed into example. But before then, take note, you always have to draw your horizontal line clearly before drawing your line of sight. So you always have to start with this horizontal line before you continue with your line of sight. So the example here says a flagpole is 18 meters high. A student stands 24 meters from the pole. Find the angle of elevation. So first things first, a flagpole is 18 meters high. So you have to draw the flagpole. So this is your flagpole. You can assume this flag. So if this is your flagpole and they said it's 18 meters high, right? 18 meters high. So one after the other. Then a student stands 24 meters away from the pole. So again, like I said, see, I even made mistake here. You have to first draw your horizontal line. So there is a horizontal line definitely. Then the flagpole is resting on the horizontal line. So this is a horizontal line. Then the flagpole is resting on the horizontal line. So a student is standing what? 24 meters from the pole. So if this is the pole and the student is standing 24 meters, definitely the student cannot be standing up. The student has to be standing on this horizontal ground. So you can just assume this to be where the student is. So if the student is here and they say it's 24 meters from the pole, it means here is 24 meters. Then finally they said find the angle of elevation. So the angle of elevation simply means he wants to look at the top of the pole, of the flagpole, the top. So the angle of elevation will be from here down here. And this is the angle formed, theta. So basically this is the diagram. So you have here is going to be your opposite. Here is going to be your adjacent. I'm sure you are familiar with identifying the sides by now. Don't forget your right angle. And here will be your hypotenuse. So what we are interested in finding is this angle of elevation, which is theta. So since you have your opposite and your adjacent, it means you have to use your tan. So you come over here, you have tan theta is equal to add opposite over adjacent, and the opposite is 18. over adjacent is 24. So when you divide 18 by 24, tan theta is equal to, you have 0.75. So I taught you how to do that. Use your calculator, divide it. You have that. Then what you are interested in finding is your angle theta. So to find your angle, your tan will now become tan inverse over here. Remember, we've done it also. So it will become tan inverse of the value there. So, and I've taught you how to find tan inverse. Use your calculator. Press shift, then tan, then the value. When you do that, you'll be having 36 points. You can just approximate it. So if you like, you can just say your theta is approximately 37 degrees to the nearest whole number. So this is the angle of elevation right here. So here is 37 degrees. Question 2. Find to the nearest meter. So this one they've given us how to approximate. We're approximating to the nearest meters. The length of the shadow of a 4-meter flagpole when the elevation of the sun is 58 degrees. So in this case, you're also having your horizontal plane. Then the flag is certainly resting there. So this is your flag, 4 meters. And your sun is around here. This is your sun. Right? So if the sun is shining here, definitely the rays of the sun will be what? Will be here. So this is the sun rays. Right? If the sun is right here, the rays will definitely be here. Now, if the rays of the sun is here, definitely its shadows will be casted down on the horizontal. I hope you understand what I'm trying to explain. So if this is the sun, this is the rays, the shadow of those sun rays will be casted on the ground, on the horizontal ground. Right? So this is the shadow of the sun. Right. So coming back to the question, any other details given? Good. They say, so when the elevation of the sun is 58 degrees, we are to find what? The length of the shadow. We are finding length of the shadow. And the elevation is what? 58 degree. So if the elevation is 58 degree, it means here is 58 degrees. And you have to find the length of the shadow. And length of the shadow, we said the shadow will be casted on the horizontal. So it means we are looking for this very point. So you can just call it X. Then remember to put your right angle. So this is how the diagram is going to look like. Now, to identify the side, here is your hypotenuse, here is your adjacent, here is opposite. So since we are looking for adjacent, we have opposite, we have our angle. Again, we are using tan. So you come over here, your tan, in this case 58, is equal to opposite is 4, adjacent is not known. So you find your tan 58. Tan 58 in your calculator, I'm having 1.6 is equal to 4 all over x. So you make this over 1 and you cross multiply. That would be 1.6x is equal to 4. So since you are looking for x, you divide both sides by 1.6. Divide both sides by 1.6. So 1.6 cancel 1.6. You are left with x there is equal to 4 divided by 1.6. So you have your calculator, divide that. I'm having 4.2.499. So the question said to the nearest meters. To the nearest meters. So to the nearest meters, more like whole number. So what is the value here? 2. The value here is 4. And 4 is round down, not round up. So it means here will just be 2. Since 4 is round up, it's round down. So to the nearest meter, the shadow or the length of the shadow rather would be 2 meters. Example 3. The angle of elevation of the top of a tower from a point on the horizontal ground 40 meters away from the foot of the tower is 30 degrees. Calculate the height of the tower to two significant figures. So first thing first again, your horizontal ground is very important. Then the angle of elevation of the top of a tower. So it means you have a tower. So you have to draw it. Now, let me just assume my tower is on this side. Right. So if my tower is here, and this is the top, this is the bottom, this is the top, right? So since there's an angle of elevation, right, of the top of a tower from a point on the horizontal ground, so you can come over here and choose your point. So let me assume this is my point P, this is where I'm standing, and the angle of elevation to the top of the tower will now be here. So this is the angle of elevation. 40 meters away from the foot of the tower. 40 meters away from the foot of the tower. So this is the foot of the tower, foot of the tower. This is the top of the tower. So since they said, the question said the point where I'm standing is 40 meters away from the foot of the tower. So automatically here is 40 meters. Then the angle of elevation, because that is what we are talking about, is 30 degrees. So here is 30 degrees. So you can see the way I'm solving, I'm drawing the diagram by following the question one after the other. That's how you do it. So calculate the height of the tower to two significant figures. So you come over here, the height of the tower is here. You can call it H, height of the tower. So with this, you remember to put your 90 to enable you identify the side. So that is your hypotenuse. This is definitely your what? Adjacent. And this is your opposite. So it means you are looking for the opposite. And you have adjacent. So again, you are using tan. So tan 30 will be opposite over adjacent. So coming over here, tan 30 is equal to opposite is 40. Is it 40? Okay, opposite is H. So opposite is what we are looking for, the height of the tower over the adjacent. The adjacent is 40. So from those values I gave you from that table in the previous lesson, you could check again or use your calculator. Tan 30 will give you 1 over root 3. 1 over root 3, which is equal to H over 40. So from here, you cross multiply, you have H root 3 is equal to 40. Then since you are looking for H, you divide both sides by root 3. Root 3. Root 3 cancel root 3. H will be 40 divide root 3. So when you use your calculator to do that, you're going to be having to two significant figure, you'll be having 23 meters to two significant figure. Two significant figure. So this is going to be the height of the tower. The height of the tower. Now, common mistakes that students make is that sometimes because you hear angle of elevation, you mostly will think the angle will be at the top. So no, the angle is not at the top. So coming back here is properly explained there. You see, so the angle is always here. The angle is not at the top. When you do this, it's no longer angle of elevation. So please take note of that. That in elevation, the angle is mostly drawn at the bottom, not at the top. Then most students also forget the horizontal line. So please ensure to always start with your horizontal line. Take note, the angle is always drawn where the observer is standing. Now that is why the angle is what is at the bottom. Because if this is my horizontal line and this is the vertical line, and I want to look at this top, I'm standing here. I want to look at this top. So since this is my point where I'm standing and I want to look at the top, my angle will certainly be here. So the angle is always where the observer is standing. So in this case, the observer is standing here, the angle will be here. So take note of that. Now try this at a point 20 meters from the base of a water tank. The angle of elevation of the top of a tank is 45 degrees. What is the height of the tank? Try this and drop your answer in the comment section. In our next lesson, we'll be looking at another aspect of what problem, which we call angle of depression.